In the first video we looked at counting methods, and we can use a fundamental counting principle or method to figure out how many outcomes there are, but there are other things we look at as well. So counting problems can also involve determining the number of different arrangements. So I want you to focus on that. How many different arrangements do you have of objects? So now we're going to define what a permutation is. So for a permutation, what we're going to look at is it's an arrangement of a group of distinct objects, and I want to key on the word distinct. Distinct means each object is different. But if you look at the arrangements down below, you got A, B, and C. Each letter is unique. It's different. It's a distinct object. So it's an arrangement of a group of different, unique objects in a certain order, which means order makes a difference. Order is important. If I turn the letter A and B around, I get a different word or arrangement of letters than if I had A first, B second. So it's an arrangement or a group of different or unique, distinct objects in a certain order that is called a permutation. Okay, so a permutation means that we can turn the letters around in different orders and we get a different outcome. We can't repeat these elements inside these distinct objects, and we know that moving them around in different ways makes a different outcome. So we got the letters A, B, and C. You can see that there's a list of 6 different outcomes that are possible. If you go A, B, C, A, C, B, and so on down the line, there's 6 different arrangements of those 3 objects. We want to be able to have an efficient way of counting how many arrangements there are. So this is where our concept of a permutation evolves into a new kind of writing. So here's what they do typically. We've got 3 letters that we want to put in 3 different locations. So our first letter, when we choose to put a letter in that first location, we can either put an A, a B, or a C. So what we say is we've got 3 choices for that first letter to put in there. But once we park one of these letters, for instance, if I park A there, then A can no longer be used because it can't be repeated. So then when I go to my second letter, I'm only down to two choices, B or C. So I only have 2 choices left. And once I select one of those, say I select C, then there's only 1 choice left then for our third letter. And that means we only have 1 choice of that. So if you look at these numbers, 3, 2, 1, and you multiply them together, it comes up with your total number of permutations or arrangements of these distinct objects. Now they're going to bring in the word and the idea of factorial. It says the product of 3 times 2 times 1, just highlighting that, can be written as 3 factorial. That's a 3 with an exclamation point, is called 3 factorial. 3 factorial is an efficient way of writing long products. And our long products start at the top number and count down by counting numbers down to 1. So in words, we have a factorial is the product of all the counting numbers. So counting numbers are whole numbers like 1, 2, 3, 4, 5, 6, 7, 8, no decimals, no fractions, that begin with n and count backwards to 1. So we started with 3, counted backwards, 2, 1, and then you stop. You don't go to 0. They do have 0 factorial is defined to be 1. So here is the short or the skinny of 0 factorial is equal to 1. 0 chances. There's only one way of doing that. So here's a factorial notation symbolizations. We're going to use that in our next calculations. So it says the number of permutations of n distinct object is n factorial. So that's a pretty important statement they made here. The number of permutations of n distinct object is n factorial. So let's look at an example here. There are 8 finalists in the band competition, and how many different ways can the bands be ranked if they cannot receive the same ranking? So we have 8 bands. There are 8 distinct bands. They can come in 8 different orders. So what we want to do is we want to rank them. So we want to identify who gets first place, who gets second place, who gets third place, and so on. So we're going to keep making this list. So let's come back here to first place. How many different bands could get a first place award? And that would be, we got 8 bands, any one of 8 bands. Once we award someone first place, they can also get second place, so then how many bands are there to select to get second place? Since we already used 1 band, we're down to 7. And this process continues. Once I've selected first and second place, then there's only 6 bands left to get in the third spot, and then there's 5, and then we can go to 5th, 6th, 7th, and 8th. And what we're doing is we're going to be counting backwards, just as the factorial notation says. There's now only 4 ways to award 5th place. There's 3 ways to award 6th. There's only 2 ways to award 7th. And once you've awarded 7th place, there's only 1 band left to get ranked in the 8th position. So this is how you calculate how many arrangements of n objects, 8 bands, and 8 finishes. So they write it as 8 factorial. And 8 factorial is this product: 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now fix that fancy 6. Now if you simply multiply those together, you will have your product. And I'm not so good at multiplying all those numbers together in my head, so here's what I'm going to do. I'm going to use the assistance of the calculator. I got 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I didn't look up, so I want to make sure I got them all in there. And we can hit enter. It should be 40,320 different possible ways. 320 possible arrangements or outcomes of 8 bands finishing in 8 different places. Now, there is a nice little feature on your calculator you can use to do that. It's under your probability. So you're going to want to be able to go onto your probability and your math key. And your math key, the PRB, is your probability. If you notice, there's a factorial sign there. That is your exclamation point. So that's where you can find it. So I'm going to show you how to use that. So if I've got 8 objects, like 8 bands, and they're going to get 8 places, I can push my 8, and I can tell the calculator I want you to calculate a factorial. So you hit your math, go to probability, hit your exclamation point, and that says it's going to calculate a factorial of 8 factorial. That's 40,320. Eliminates a lot of busy work with writing that out. So anyway, factorials is an important part of this, and also a permutation, how you can count how many arrangements there can be made from an n number of objects.